Hello again to you all for the second podcast of week 2. Once again, lucky you, we are in a review topic, and this is one of the last things you would have covered in Science 10, the chemistry part of that course. Mass amount calculations is kind of, in a way, they sound like the same thing. But the key thing here, guys, is mass, of course, is measured in grams, whereas amounts are specific to the number of moles. So they are definitely two distinct items. Now, both of these can be related. This is logical because it's grams and it's moles by molar mass, grams per mole. All right. Here we go for a formula. The good news is this is one of those formulas that is on your formula sheet. You just have to make sure that you access it. Reminder to you, because this isn't new, it is review, that N is equal to amount. And that's quite often the language that you'll see for it. It is, of course, the number of moles. Now, moles is spelled M-O-L-E-S, but the actual unit for this is pronounced the same way but spelled differently. M-O-L. When we deal with mass in this equation, it's really important that we have consistent units. Every single time, no exception, mass needs to be in grams. So if you have milligrams, kilograms, or something like that, you're going to have to go through a conversion. Capital M, like we learned in the previous lesson, stands for molar mass, which of course is in grams per mole. Now, I actually find the units for that super helpful for determining some of the variations of the formula. Think about this. If molar mass is in grams per a mole, well, here is the formula, guys. Grams is mass, moles is N. Oh, that simply means then that capital M is equal to lowercase m over N. There we go. And the other variation of this formula, if you rearrange it again, is going to be getting mass by itself, where mass is equal to N, the number of moles, times the molar mass. So there's one formula, here's another formula, and there, of course, is your original one. All three variations. Please, if you remember, I said this in one of the last classes we had together, actually in the HGA building, said do not use this ridiculous triangle method to rearrange your equations. I know this is one of those ones with 3 variables, but I want you to go through things algebraically. Trust me, you need to get into the habit that algebra is your fallback, not a silly triangle method. Let's go into questions. Key things similar to when you did the combined gas law is reading carefully. For instance, when you're asked amount, your brain needs to go that you are looking for N because amount stands for number of moles. This is extremely important as well. Calcium carbonate. You need to know what chemical you're dealing with so that from that you're going to be able to figure out what molar mass is. And equivalent to, hey, there we go, good news, mass has been given to us. So we're in pretty good shape in terms of getting what we need. Mass is given, molar mass you can find, and N, the number of moles, that's the goal of the whole question. How do we start? Well, write down what you're looking for, N equals question mark, and write down, of course, what you know. M, mass, is 27.5 grams. Now, even though molar mass isn't given to you, you can figure it out. Remember to think about your formulas. Calcium is 2 plus, carbonate, CO3, 2 negative, which means the molar mass of this, and write out the formula, the 2 plus and the 2 negative are going to balance. So we have CaCO3 equals, this is where I would expect you to start simply number crunching on your calculator, guys. Take the molar mass of calcium, add it to the molar mass of carbon, add it to 3 times the molar mass of oxygen, and you will get 100.09 grams per mole. Highly recommend that you try to number crunch that. Make sure you're getting it right. Okay, moving on. Next step after your givens is, of course, write down your formula. N is equal to little m over big M. Plug in what you know. We have 27.5 grams You must include units. It is an always habit, not a sometimes habit. Include it. Divided by 100.09 grams per mole. Look what happens. Grams cancels out. We're left with moles, which is exactly what we want. Equals 0.2747 ... Keeps on going moles. Back to the original question. 3 sig digs is what controls things because of that mass. So N is equal to 0.275 moles. You could also, if you wanted to, write it into scientific notation. 2.75 times 10 to the negative 1 moles. Either answer is great, but keep in mind, regardless, 3 sig digs. And I cannot say enough how important it is to have the units of moles in there. Okay, next question. Check out another one. Same dealio. Pay close attention, please, to what you've been given. So, mass is our goal. This is what we're looking for is M. You have how many moles, in other words, N, of the substance. Then, last thing, we've got zinc phosphate as our actual chemical. That's huge because if you've been given the chemical, you have a way to figure out molar mass. Take note again, zinc 2 plus, this is an ionic compound, phosphate, PO43 negative. Think about how those different ions are going to balance. Okay, goal of the question, mass. So mass equals question mark. N has been given 0.0027 moles. Molar mass, write the formula beside it. Drop and swap means that we're going to have zinc, 3 of them, bracket, PO4, and we're going to have 2 of those, right? Drop and swap. Equals, think about again when you do this molar mass, 3 zinc, plus there's 2 phosphorus, plus there's 8 oxygen. You're going to get a grand total of a pretty high molar mass, 386.17 grams per mole. Okay, let's keep going. You're going to have to rearrange that formula. If the original is N equals M over capital M, and we're trying to get little m by itself, well, the big M's in the way. So times by capital M on both sides, those cancel out. We're left with mass is equal to N times capital M. Plug in what you know with units. 0.0027 moles times the molar mass, 386.17 grams per mole. Type it on in. Don't round to the end. 1.0426 ... grams. Go back to the original question, guys. Think about this. You are dealing with only 2 sig digs. Those leading zeros are not significant. So that means that our mass is equal to 1.0 grams. Again, 2 significant digits. Hopefully this is feeling okay. Like I said, these are review topics, stuff that you would have covered in Science 10. But remember, I'm super picky about units and super picky about significant digits. Let's look at the last question. This one's a little bit different. An unknown chemical. Oh, so no formula to find here. That gets a little more interesting. You're told that you get 3.86 moles of the compound. Okay, that's useful. So we've got N. As we keep on going, you're also told that the mass of this thing is 275 grams. Okay, that's useful too. So we've got M. The whole point of the question is to figure out its molar mass. So even though this is an unknown chemical, as long as we have the other 2 values of N and mass M, that molar mass is totally doable. Check it out. Write down what you know. N is equal to 3.86 mole. Mass is equal to 275 grams. Therefore, what is molar mass? Again, when I do the formula for molar mass, I just tend to think about the units. Molar mass equals grams per a mole. Grams is measurement of mass. Mole is a measurement of, well, mole. So there's your formula. Capital M equals lowercase m over n. Plug in what you know. 275 grams divided by 3.86 mole equals, again, don't round yet, 71.2435 ... grams on top, moles on the bottom. We're at 3 sig digs for this question. The molar mass is equal to 71.2 grams per mole. Even though molar mass is usually expressed to 2 decimal places, in this case, we are completely constrained by the 3 sig digs of the number of moles and the 3 sig digs of the mass. There you have it, folks. You should move on, start to work on the homework. There's 3 more questions that you can do now, number 2, 3, and 4, and that is the end of the second lesson of this week.